One little bit of chemistry with you here, because I'm almost positive this is going to be on your next exam. So exam 3 is going to cover chapters 5 and 6, and so this is really important. In fact, I had this exact conversation just yesterday with an international carbon trader. So I've got a buddy here in town. His name is Keegan Eisenstadt. He's got his own company called Clear Sky Climate Solutions. So he will actually broker deals between the European Union and indigenous tribes in South America. So you're a tribal member, you're in South America, you're living in the jungle, and you're seeing your neighbor get rich because he's now farming. You know, he's growing rice or sugar cane or whatever. You're like, oh, I want to be a rich farmer like him. What do I have to do? Well, I got to clear cut my forest, you know, and extinct another set of species, whatever. So the service that Eisenstadt does is to take somebody in Europe who's following the Paris Accord or the Kyoto or the Copenhagen or whatever, and is willing to put money into a fund that sequesters carbon. What sequesters carbon? Well, plant life on Earth. And where does it happen the fastest? Near the equator. So Eisenstadt will take money from the EU from polluters who said, well, you know, for every ton of CO2 I emit, I'm gonna give you $10. Here's $10 on the carbon market. Here's my penalty, $10 per ton, and tack that on, you know, just tack it on the electricity bill. You know, Northwestern Energy. So guys, here's another. Sorry, your electricity's not 10 cents a kilowatt hour. Now it's 11 cents. Why? Because we're paying the indigenous family in South America to not cut down the forest so they can suck up the carbon so we don't have to invent some other weird technology. It's already been invented. It's called a tree. So that's the market that he lives in. So my question to Keegan, as I said, is it a ton of carbon or is it a ton of carbon CO2? Or just CO2. So let's look at that. And here's the chemistry. I'm looking at box 5.3 because there's a big difference. So carbon has an atomic weight of 12, and we're going to add a pair of oxygens to it, O2. Oxygen has an atomic weight of 16, so 2 times 16 becomes CO2, and there's your 44. So 12 plus 32 equals 44. We're just doing atomic scale arithmetic. So if we've got 1 ton of CO2, what's the volume of a ton of CO2? How big is that? The idea. Here's the way to think about it. If we've got here's a if you take my 200 level courses, we'll dive into this in some more level. But if I've got 1 cubic meter of air, that cubic meter of air weighs 1.2 kilograms. Now, if I put a cubic meter of air in a suitcase, would I have to pick that up and feel that weight?
No.
No. Why? It's because your air is already floating in air. It's the same thing like you go underwater and put water in a suitcase. Is the water? Do you have to pick? No, because the water is already floating in water. But air has mass, so 1.2 kilograms. So CO2, CO2 is a little more dense than air, not a whole lot. You'll go look it up. Let's just say it's 1.3 or 1.4. I don't know exactly what it is. Just go look it up. But so a ton. So this is 1 kilogram, and I'm just going to say 1 ton is approximately 1 metric ton. It's not, but it's close. 1,000 kilograms is about 2,000 pounds. So 1 ton is approximately 1 metric ton. So a ton of CO2 is approximately 1,000 cubic meters. And what's that? Well, it's just a box. And I'm sorry I'm drawing it so small here, but it's just a box that's 10 meters by 10 meters by 10 meters. So sometimes you'll see that someone will put a big box out on a football field, and it's in one corner of the end zone. You know, it's 10 yards or 10 meters long, and it's 10 meters high, and it's 10 meters wide. So that's a ton. You know, that's 1 ton of CO2. That's how big it is at atmospheric pressure. So that 1 ton, and in fact, I'll even go to my notes here. This is a fun little text I'll show you. Keegan-Eisenstat. So what I was asking him here, I said, Keegan, there's also a difference between what's called a renewable energy credit and a carbon credit. So my question was, what is a REC? What is a renewable energy credit worth? And his answer is $5 per megawatt hour. So if I make a megawatt hour of electricity without setting something on fire, I get $5. You know, Keegan gets $5 to go spend somewhere for $5 for a megawatt hour. A certified carbon offset, carbon credit, varies from $3 to $7 per metric ton of CO2. So if I'm going, so I'll just write that out. So $3 to $7 per metric ton of CO2. So what that's saying is I made some electricity, but I didn't make this ball of carbon dioxide. Now, and I'll just draw that ball or box or whatever, and we'll just go back again. So in this 10 meter by 10 meter by 10 meter cube of carbon dioxide, if we go back to our stoichiometry, and we just normalize it. And here's kind of the fun thing. You can just sort of imagine, instead of there being moles, 10 to the 23rd, 10 to the 25th, 10 to the 26th carbon atoms in there, which were carbon dioxide molecules in there. What's it look like? It looks like this. And of course there are, again, on the order of 10 to the 26th. Because one mole is 10 to the 23rd. That's a gram. Might even be more than that. Let's just say maybe it's even 10 to the 28th. Molecules of CO2 in there. You could also just imagine there's just one big giant molecule. What's the difference? That's all that's in there. It's got an atomic mass, like I said, of 44. But of that mass, and again, we looked at the number versus the mass, going back to our stoichiometry, 12 versus 32 makes your 44. So most of it's oxygen. It's not molecular oxygen, but most of that CO2 is just oxygen. Great, groovy. So down here, there's your 12, and here's your 32. So that's this $3 to $7 per metric ton. Make sense? That you did not put into the atmosphere. Or maybe you sequestered it. I mean, maybe you went out and planted a tree farm somewhere, and at the end of the year you take a picture. How much do those trees weigh? Well, how much carbon is in those trees? Pretty easy to answer. We already know that. Sitting right there. That's how much carbon's in the trees. That's how much carbon you sequestered out of the atmosphere. So there's your carbon credit. Make sense? So it's a neat, wild market that's occurring. Okay, so let's just get through some technology here. So uses of coal. So small retort for making town gas. This is just ancient pyrolysis. You know, if you remember, right here, here's the volatile matter. This is stuff that will still burn. So there's carbon monoxide in there. There might be a little bit of methane that comes off, you know, carbon with the hydrogen. These are just ovens where the coal is heated. Kind of the wild thing about it is like, how do you heat the coal? Well, the volatile matter itself, a certain fraction can come back, combine with oxygen, heat the coal, and what's left over actually goes out to burn somewhere else to keep the lights on. Town gas.
So it's kind of like a priming stage?
You could think of it as a priming stage. Yeah, you could. You sure could. Next one here is a telescoping gas holder. This is kind of wild. I have one of these. The program has one of these for holding hydrogen. We've got a 25 kilowatt hydrogen electrolyzer. So as this thing fills up, it's just a big old ball of gas. Don't light a match. No smoking, please.
I don't remember seeing one of those around here.
Yeah, no, you wouldn't. This is typical telescoping gas holder, greenish number one. No, I mean, what you'll see instead are the propane tanks over here. It's compressed. You know, rather than have this giant facility, you run your compressor and you've got your propane, and you might even compress it to the point that it's no longer a gas. It's now a liquid. Same thing. You look at your lighter, butane. That's there's 4 carbons in butane, and you compress it enough, it's now a gas.
Does this structure utilize electrical charges or static to collect the hydrogen from the atmosphere?
No, and I think this is just going to be a town gas, just kind of a mixture of that volatile matter. There's no real electricity, just pneumatics.
I just meant, how does it collect?
Just from pressure, you know, as the during pyrolysis, you've got some heat, not as high a pressure as you'd see in a steam plant, but just enough to, like, just blowing up a balloon. Yeah. Okay, uses of coal. So all kinds of goodies can come from coal. It doesn't not necessarily have to be burned. So there's the coal gas that I just mentioned. There's in England they call it mains. That's just their utility. Here we call it natural gas. Light oils. So these are things that are coming off at less than 200 Celsius. Benzene, highly cancerous, but used actually to kill bugs. You can buy benzene for an antibacterial. It's carbon-6, hydrogen-6, middle oil, heavier oil, residue of pitch. It goes in industry. So at the end of the day, here's the fossil fuel industry not really wasting much of its product. In fact, if you want a really good read, somebody that kind of got rich off of waste products, go and read the book Mauve. One man invented a color that changed the world. I got a read on this. It was kind of a big inspiration for me. There were these old ponds or pools behind some of the refining industries back in the Victorian era, and it's just this nasty purple. And the guy's like, well, what if I just bottled that and started dyeing clothes with it, and all of a sudden this nasty toxic sludge now becomes the height of fashion. So again, just innovation in the industry, taking something that otherwise would be, and obviously there's I don't see anything that says dyes here, but somewhere off is a little bit of dyes. The company in town, Blue Marble Biomaterials, if you hadn't heard of them, does very similar things. Their big plan was to go out in the ocean, harvest algae, turn into diesel fuel, and great, now you've got an $8 per gallon diesel fuel. Buying that? Nope, sorry. But their initial investor says, smells like blueberries. Willy Wonka. Here we go. Blueberry syrup. And now you've got a product that's go and buy a bottle of blueberry syrup from the shelf, dollars per gallon. Robert's kind of like grimacing over here, but yeah.
Flavorings.
Well, artificial, maybe, yeah. Not going to have your antioxidants in there that an actual berry would. But what are you going to do with it? It's got to go somewhere. So can't do nothing. Got to keep moving.
Like using beaver testicles to flavor your food.
Yeah, that's actually real.
Oh, really?
Well, that's good.
That's
There's nothing about a beaver that tastes good.
okay, on that note, I'm just going to take a little break.
Get to the good stuff, man. What about the Coke?